Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the gradient of a straight line. So the gradient of a line is just a number, and that number indicates how steep the line is. For some reason, I'm not sure why, we use m to denote the gradient. So let's draw a couple of lines and look at them. So look at this line here. Now we can't tell what its gradient is from that. The gradient doesn't have a meaning other than to compare straight lines. If I draw another line like this, you can see that the red line is steeper. This means it has a larger gradient than the yellow line, which is flatter. Now, even though I don't exactly know yet what the gradient of each line is, I know the gradient of both the red and the yellow line is going to be positive. I know that because the lines lean to the right. So if lines lean to the right like this, they have a positive gradient, and predictably, if they lean left, they have a negative gradient. So let's look at this black line here. So it's a perfectly vertical line. So what I mean by leans left, I mean I take this line and I shift it so it's going to the left. That's negative gradient, positive gradient to the right. So we start perfectly vertical. This one here now, black one, leans left, so it would have a negative gradient. So it turns out sometimes the gradient's neither negative nor positive. If the line is perfectly horizontal, the gradient is 0, and perfectly vertical, it is undefined. So when we go through more of the definition of gradient, we'll see why that is. So this is all well and good, but how do we actually calculate the gradient? Well, we can calculate the gradient if we're given a diagram of the line, or also from the table of values. So the gradient is the number by which y values increase each time the x values increase by 1. So hopefully that'll become a bit more clear as we look at finding the gradient in each of these table of values. So let's look here. So each time x is going up by 1, what's happening to y? It's going up by 2. So here, the gradient is 2. If I were to plot this line by plotting each of these points as we did in the previous lesson, it would have gradient 2. What about this table of values? Well, again, each time x is going up by 1. What's happening to y? It's decreasing by 3, or we're minusing 3 from each number. So that means here the gradient in this table of values is minus 3. So these next two examples are a little more difficult. So this one's more difficult because what's happening is x is not going up by 1 each time. In this table of values, x is actually going up by 2 each time. Each time x goes up by 2, y goes up by 1. So the gradient here is going to be 1 over 2. Each time x goes up by 2, y goes up by 1. So that means if x were to go up by 1, say minus 3, the number in here would be 8.5. If x were to go up again by 1, this number would be 9.5. What you could see, each time x goes up by 1, y is going up by 0.5 or a half. So that's why the gradient here is a half. So this one here is even trickier because x is not going up by the same amount each time. It goes up by 4, and then it goes up by 5, and then it goes up by 3. But that's okay because each time x goes up by 1, y will go up by the same amount. So what happens is when x went up by 4 from minus 5 to minus 1, y went down by 8. We subtracted 8. When x went up by 5, y went down by 10. When x went up by 3, y went down by 6. So the gradient here, you can write it as minus 6 over 3, or minus 10 over 5, or even minus 8 over 4. Each time you get the same answer. Minus 6 over 3 and minus 10 over 5 are both equal to minus 2. This is saying that if x were to go up by 1, y would go down by 2 each time. And this is what this formula here means, rise over run. Rise is the change in y, which we write like this with the little triangle, and the run is the change in x. The gradient is how much y changes divided by how much x changes. And that's how we got it here. What was happening? X went up by 4, the change in x was 4, and when that happened, the change in y was minus 8, so the gradient's minus 8 over 4, which gave us our answer, minus 2. This definition becomes a lot more useful when we're looking at the graph of a line. So let's look at a few of those examples. So here on the Cartesian plane, we have 4 different graphs labeled A to D. We're going to calculate the gradient of each using the formula m equals rise over run. So remember, rise is the change in y, how far we go up, and the run is the change in x, how far we go across. So let's start with line A. So all we need to do to find the gradient, we need to know 2 points. So we know that A goes through this point here and this point here. So always start at the leftmost point. So what happens to go from this point here to this point here? We need to go across 4 and we need to go up 4. So the gradient of A, I'll call that MA, is rise is 4 because we've gone up 4. We've gone across 4. 4 divided by 4 is 1. Line A has the gradient 1. So let's look now at line B. We'll calculate its gradient. So it goes through the point here at 2. That's the point 0, 2. This is the point 3, 0. So what happens? We start from the leftmost point. So we're going to start here and end up here. So to do that, we need to go across 3, always go to the right. So we've gone 3 to the right and 2 down. So when calculating the gradient of B, note it should be negative because B leans to the left. Line A leaned to the right, that's why its gradient is positive, but this gradient is negative. You always start at the leftmost point. So what I've done is I've gone 3 to the right and 2 down. So the gradient is the rise or the change in y values on top. So the y value has gone down from this point to this point. The y value has gone down by 2. So I'm going to put a minus 2 up. This minus means that I've gone down. So I've gone down 2 and across 3 to the right. So the gradient of B is minus 2 over 3. You can have a gradient that's not a whole number, just like we did on the previous slides with one of the table of values. So let's look now at line C. So line C is perfectly horizontal. Its gradient is 0. The gradient of any horizontal line is 0. So why is that? That's because the rise is 0. There is no change in y values. So if you have 0 divided by something, you always get 0. No rise, the rise is 0, it means the gradient's 0. What about the gradient of line D? Well, here, there is a rise, we are going up, but the run is 0. When the run is 0, you are taking a number and dividing by 0. You can't do that. That's why the gradient of any line that's perfectly vertical is undefined, because the run is 0, so the gradient would be something divided by 0. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.